Nixon Corporation manufactures computer monitors. The following data gives the numbers of computer monitors produced at the company for a sample of 30 days. So here they're telling you the N is going to be 30. Here you need to calculate the three quartiles, lower quartile, the median, which is the second quartile, and the upper quartile, the interquartile range. You need to find the approximate value for the 65th percentile, the percentile rank of 32, and then something new. Here they want you to find the first decile. Take a minute, enter the data into your calculator, do the 1var stat test, and supply a picture. And I'll put my picture of my 1var stat test up on the TV in a moment. So here we have 30 numbers, which matches what the data says. And I want you to take the picture of this 1var stat test on your calculator. Here are the three quartiles. Q1 is 25. The median Q2 is 28.5. Upper quartile Q3 is 33. And then for the interquartile range, the IQ, here we're going to take Q3 minus Q1. So it looks like here we're going to be left with 8. Now what we need to do is we need to find the approximate value of the 65th percentile. So when you're given a percentile, what you're going to do is you're going to use a formula. You're going to take the percentile rank, and you're going to divide it by 100, and then you're going to multiply it by the number of data. So you're going to take your percentile rank divided by 100 and then multiply it by the number of data. When you do this computation, this is going to give you the place in the order to find your answer. So what you're going to have to do is you're going to have to sort the data in order from smallest to largest. So I'm going to do that first. I'm going to go to Stat and Option 2 for Sort in Ascending Order my data. So I want you to sort your list in ascending order and take a picture of your sorted list and supply it on the worksheet. And now what we're going to do is we're going to take that percentile rank in the question, which you were told was 65. We'll do 65 divided by 100, and then multiply it by n, the number of numbers, which is 30. So I want you to do that computation on your calculator and supply a picture of that as well. And here, when you do that, you should be left with 19.5. Now what you're going to do is you're going to take that answer, and remember, this is the place in the order where you're going to find your answer. You're going to take this, and you always round up. What they're saying is the 19.5 place in the order. So you're past the 19th place, which means the number that's 20th in the order, that's going to represent the value that's at the 65th percentile. So here, scroll down until you see your list and then the number 20 in parentheses, and here it corresponds to the data value 31. So that's your answer. 31 is at the 65th percentile. What does that mean? That means approximately 65% of the data are less than or equal to 31. Again, this is approximate, so about 65% of the data are less than or equal to 31, meaning 35% of the data is greater than the number 31. So that's how you find a value if you're given a particular percentile rank. Now what we want to do in letter C is define the percentile rank of a particular value. In this case, we want to find the percentile rank of the number 32. So what you're going to do is you're going to count the number of data less than 32. So you have to go back to your list and count the number of numbers less than 32. Then you're going to add to that 1/2 times the number of 32s, the number of data values equal to your given value. So take the number of data less than 32 plus 1/2 times the number of data equal to 32, so the number of 32s, and divide by the total number of data, which in this case the problem told you was 30. So what we have to do now is go into our list and find the number 32. So here I found the number 32, and notice it's in the 21st spot of the order. So the number of data less than 32 has to be then 20. So I'm going to take 20, the number of data less than 32, plus 1/2 times, well, here we have 132. So we're going to go times 1, and then we're going to divide that by the total number of data in the problem, which was 30. So do this computation on your calculator, take a picture, and include it on your worksheet. So here you get 0.6833333. So this would correspond to, in traditional percents, 68.3%. But remember, we're not dealing with percent, we're dealing with percentile. They sound alike, but they're very, very different. So here you have to remember, once again, to round up. For percentile ranks, you always round up. You're past the 68th percentile, which means now you're in the 69th percentile. So about 69% of the data is less than or equal to 32. Just remember, percentile corresponds to less than or equal to. Finally, letter D, here we have to find the first decile. Now here's some information you need to know about deciles. Deciles are similar to quartiles, but for quartiles, the lower quartile is the 25th percentile, the median Q2 is the 50th, and the upper quartile Q3 is the 75th. But for deciles, as opposed to breaking the data up into quarters that quartiles do, deciles break the data up into 10 equal parts. So basically you have a little chart here. What does that mean? The first decile corresponds to the 10th percentile. The second decile corresponds to the 20th percentile. The third decile, the 30th percentile, and so forth and so on. So basically, here you're being asked to calculate the first decile, but the first decile is the same as the 10th percentile. So what we're going to do is just basically go through the procedure that we did in Part B. Here you're given a percentile. Here you're given the 10th percentile. So what we're going to do is we're going to take the percentile rank, which is 10, because the first decile corresponds to the 10th percentile. You take the percentile rank, which is 10, divided by 100, and then multiply it again by the number of numbers. So if you were asked to find the 7th decile, you would instead find the 70th percentile. So the deciles are just fancy ways of grouping the percentiles by 10. So here I want you to do 10 over 100 on your calculator, multiply that by 30, and then take a picture of your result. So here, 10 over 100 times 30 gives you 3. Remember, this is the place in the order that you're looking for your answer. So here, the third number in our list corresponds to the number 23. So 23 is our answer. So 23 corresponds to the first decile. What does that mean? That means about 10% of the data are less than or equal to 23. Here's a new data set that I want you to use. Take a moment, enter the data into your calculator. Here they're telling you that there's going to be 12 data values. So make sure when you enter your data into your calculator and run your 1var stat test, take a picture of your 1var stat test and supply it on the worksheet. Here your n value should be 12. So please label on your worksheet with this picture. Here are the 3 quartiles. So Q1 is 6. The median, Q2, is 9. And then the upper quartile, Q3, is 11.5. And how do those tie in? Well, the lower quartile is the 25th percentile for the data. The median, Q2, is the 50th percentile. And Q3 is the 75th percentile. Here our IQ, interquartile range, Q3 minus Q1. Looks like here you have 11.5 minus 6. Or it looks like you're going to have 5.5. Now we have to find in letter B the approximate value for the 55th percentile. So here you're given the 55th percentile. Anytime you're given a percentile, we're going to use that formula. We're going to take the percentile rank, I'll abbreviate it as PR, percentile rank, over 100, and then we'll multiply it by n, the number of numbers. So anytime you're given a percentile rank, you take the percentile rank, so in this case 55, you divide it by 100, and then multiply it by the number of numbers, which in this case is 12. Do this computation on your calculator and supply a picture of that work. So here you're left with 6.6. Remember, this represents the place in the order. So I want you to sort your data in order. And here we're going to go to 6.6, so we're going to round up to 7. So that means the 7th number in the list corresponds to the value that's at the 55th percentile. So take a picture of your calculator's list sorted. Here the 7th number in the list corresponds to the data value of 9. So that's our answer. That means about 55% of the data is less than or equal to 9. About, give or take. For part C, now we're finding the percentile rank of 7. So anytime you are asked for the percentile rank, what you're going to do is you're going to use the formula, the number of data less, plus 1/2 times the number of data equal, so in this case the number of 7s, divided by the total number of data. Take a moment, try to find the percentile rank of 7 in this data value. Find the number 7 in your sorted list and take a picture of that 7 and supply it on the worksheet. So here, take a picture of your number 7. Number 7 is in the 5th spot. So the number of data less has to be 4. So we take 4 plus 1/2 times. Here the number of data equal, so we're looking for the number of 7s. And here, since there's only 1 7, we're going to go 1. So we're going to go 4 plus 1/2 times 1 over 12. Do that computation on your calculator and take a picture. So here you're left with 0.375. If we would turn that into a traditional percentage, that'd be 37.5%. But remember, we always round up. So in this case here, 7 is in the 38th percentile. Remember, we're not going to write 38%, we're going to write 38th with a TH. That means that about 38% of the numbers are less than or equal to 7. Finally, in letter D, we have to find the 3rd decile But remember, the third decile, that's the same as the 30th percentile. So anytime they ask you to find a decile, what you have to do is convert it into a percentile by multiplying it by 10. So here the third decile is the same as the 30th percentile. So here it's like letter B. Here we're given a percentile. We're given 30. So here what we're going to do is we're going to take the percentile, 30, divide it by the 100 to convert it into a sort of percentage, and then multiply it by n, the number of numbers, which is 12. So do this on your calculator and take a picture of the computation. The percentile over 100 times your n, the number of data values. So here we get 3.6. Remember, this is the place in the order that you're looking for your answer. So here we're going to round up to 4. So that means the fourth number in our list, in this case 6, corresponds to the third decile. So basically what that means is about 30% of the numbers are less than or equal to 6. So 6 is going to be our answer. For the next problem, they're giving you the lifetimes in years of 30 AA batteries. And what we need to do is we need to construct a frequency distribution, a relative frequency distribution, and a cumulative frequency distribution, and histograms for the data, and then answer some percentile questions. Take a minute or two, enter all 30 numbers into your calculator, so that's what your n value should be, and then take a picture of your 1var stat test for your data. Make sure you include a picture of your 1var stat test. Here, mine are up here in green. Yours clearly shouldn't be in green. And what we first need to do is we need to set up our intervals. And what we do is we always start the table with the smallest data value. So here our minimum data value is 3.4. So that's going to be the starting point of our first interval. And now what we're going to do is we're going to take the range of the data and we're going to divide it by the number of intervals. And you'll always be told how many intervals to use. Here, we're going to be using 6. 1, 2, 3, 4, 5, and 6. So here we're going to take the range. Well, the range is the max minus the min. So here we're going to have 9.9 minus 3.4, or here our range is going to be 6.5. So here we're going to do 6.5 divided by the number of intervals, so divided by 6. Do this division on your calculator and take a picture of the result. Here, you're left with 1.0833333. Now, what are we trying to do? We're trying to find the class width, the interval size. Once again, we're going to round up. But we're going to round up according to the data that's given to us. Here, the data is to the nearest tenth, so we're going to round up to the nearest tenth. So this is our tenths place, the 0. The 8 is going to kick the 0 up to 1. So here we're going to be left with 1.1. And that's going to be a key number. That's going to be the interval size. What I'm going to do is take this minimum value, and I'm going to keep adding 1.1. So here I have 3.4 plus 1.1 is 4.5. 4.5 plus 1.1 is 5.6. 5.6 plus 1.1 is 6.7. Then 7.8. And then 8.9. So those are the starting points of my 6 intervals. Then what I'm going to do is I'm going to figure out the ending points, the upper limits. Here the second interval starts at 4.5. So here this first interval has to end at 4.4 so that the next one could start at 4.5. Here the third interval, it starts at 5.6, which means the second interval has to end at 5.5 so that the next one could start at 5.6. So what I'm going to do is I'm going to figure out the ending point. So here this is 6.7, so the previous interval has to end at 6.6, and then 7.7, 8.8, and 9.9. So this is how you go about setting up your intervals. Now what we're going to do is we're going to set up a histogram to calculate the frequencies of each of these intervals. So the histogram is the third type of graph. Kind of looks like a bar graph, but the bars are attached to each other. And what we're going to then do is we're going to press the window button and enter in the viewing window which establishes these intervals. So here, x min is the smallest data value, so that's 3.4. X max is where the last interval ends, so here the x max is going to be 9.9. And the x scale is the size of the interval, the class width that we calculated by doing the range divided by the number of intervals. So here that's going to be 1.1. Y min is always 0. To get Y max, what we're going to do is we're going to take the number of numbers that they give you and cut it in half. So here the number of numbers that were given, n was 30. So we're going to be doing 30 divided by 2 to get 15. And then for your Y scale, I'm going to go with 5. What that's going to do is this. It's going to draw a histogram and the top of the y-axis. So on the left-hand side, it's going to go all the way up to 15, and the y scale is 5, so it'll put marks at every 5. So basically, the graph will be showing you the 5th and the 10th value along that y-axis. So press the viewing window button and enter in these values. So make sure you press the window button after you select the histogram. Enter in these data values, and then once these data values are set up, then press the graph button. And then what your calculator will do, it will construct a histogram based on the data that's given and the intervals that you set up. So here we're going to draw this histogram in this box. This is the only histogram that you're going to set up that you don't have to label, because the viewing window that you used actually labeled it. So here's what I'm looking at as far as my histogram goes. Remember, in a histogram, the bars are pushed together. And why is this important? Because what's going to happen is, when I press the trace button, it tells me the frequencies. It tells me the number of numbers in each interval. So here, from 3.4 to less than 4.5, so from 3.4 to 4.4, the frequency is going to be 3. If I press to the right, it's going to tell me that the n value for the second interval is going to be 8. The cursor jumps up to here, it tells you the second interval, and then it tells you n is 8. So by setting up the histogram, it's going to tell you the various n values, which represents the frequencies. And if you want to check to see if you did this right, after you get to your last frequency, in this case, here from 8.9 to less than 10, so from 8.9 to 9.9, n is going to be 2, you can add up your frequencies and make sure they add up to, in this case, the number of data values, the number of batteries, which is 30. So that's how we set up our intervals, and we get our frequency column. Next, what we're going to do is we're going to calculate the relative frequency. test for flu. That's what it is. Can't get flu B again. Maybe it's another strand of flu they haven't really found yet. Either way, that's how we're going to treat it. Next up, we want to calculate the relative frequency and construct a relative frequency histogram. For relative frequency, you just have to remember that it represents the percent. So here for the first interval, from 3.4 to 4.4, the frequency was 3. So 3 of the total data values were in that interval. Well, in this case, they gave you 30 batteries. So 3 of the 30 batteries are in that interval. So to get the relative frequency, we're just going to take 3 and divide it by the total 30. In this case, when you do that on your calculator, take a picture of it, you should get 0.1. So what does that mean? That means 10% of the data. And for the relative frequency, we're always going to go to 2 decimal places. So the relative frequency for the first interval is 0.10, or 10%. Here for the second interval, from 4.5 to 5.5, 8 of the data values, so 8 of the 30, and if we do that on our calculator, or in this case 0.266, so 0.27, so approximately 27% of the data are in that interval. So the way you get the relative frequency is you just calculate percentages. Here our next interval, the frequency was 9, so we're going to do 9 over 30 on our calculator, or 30% of the data, so the relative frequency is 0.30. Do 5, 3, and 2 out of 30. Take a picture of those 3 all at once on your calculator and include it on the worksheet. And my picture is blue, so yours shouldn't be, that you include on the worksheet. And here it looks like the relative frequency for 5 is 0.166, so 0.17, 17%. 3 out of 30, that's the same as the first interval, so that's 10%, 0.10. And then here, 2 out of 30, 0.066, so 0.07, or 7%. And now what we're going to need to do is construct a relative frequency histogram. So what I'm going to do, since there are 6 intervals, is I'm going to break the bottom up into 6 parts. We're going to label the lower limit for each class, the beginning point of each interval. So 3.4 is going to start all the way over to the left, then 4.5, 5.6, 6.7, 7.8, and 8.9. You look at your relative frequencies and you see what's the biggest value. In this case, the biggest value is 0.30. So what I can do, since that's a nice round number, is I'll put 0.30 up top here. Then maybe I'll break up the left-hand side into 0.20 and 0.10. And now I'll construct my relative frequency histogram. For the first interval, the relative frequency is 10%, so I'll go up to 10%. The second interval is 0.27, so that's almost up to 0.30. So there's my second interval. The third interval is 0.30, so I'll go all the way up to the top. Then I have 0.17, so 17% for the fourth interval. 10% again for the fifth interval. And the sixth interval is 7%, so I'll go a little bit less than 10% to construct that. So that's how we're going to construct a relative frequency histogram for statistics. Next, we're going to fill in our cumulative column. And our cumulative column is basically a running total of how many data values you have up to each interval. So here the first interval's frequency is 3. So we're just going to kind of copy over the 3. But for the second interval's cumulative frequency, we're going to add the 3 and the 8 to get 11. So through the second interval, we're up to 11 data values. For the third interval's cumulative, we're going to add the 3, the 8, and the 9. So that's going to give us a running total of 20. For the fourth, we have 3 plus 8 plus 9 plus 5. So we're up to 25. For the fifth interval, 3 plus 8 plus 9 plus 5 plus 3, or just do 25 plus 3 to get 28, and then 28 plus 2 should give you the total of 30. Now to construct a cumulative frequency histogram, we're going to put the total number of data all the way to the left, so it's 30. Since it's a nice round number, I'll break up the sides by tens. Once again, what we're going to do is we're going to label the bottom, break it up into 6, and then label the starting points. So 3.4, 4.5, 5.6, 6.7, 7.8, and 8.9. Now we're going to construct our cumulative. So first interval, we're up to 3. So since this is 10, we go a little bit less than halfway. Then we jump up to 11 for the second cumulative. Then we're all the way up to 20 for the third interval, 25 for the fourth interval, 28 for the fifth interval, and then we're up to 30 for the sixth interval. And if you do this cumulative histogram correctly, it should look like a staircase. Finally, what we need to do is answer a percentile question. Here we want to find the percentile rank of 6.3. So what we're going to do is we're going to go into our list. We're going to sort the list in order and then find 6.3. Take a moment, sort the list of the data, and take a picture of where 6.3 is in your list. So here's my list. I notice there's 2 6.3s. Include your picture on your worksheet. Mine is in green, so yours shouldn't be. Now what you want to do is you want to take the number of data less and then add 1/2 times the number of 6.3s and divide by the total number of data. So here I highlighted the first 6.3. Notice it's in the 18th spot. So that means the number of data less has to be 17. So it's going to be 17 plus 1/2 times. Here there's 2 6.3s, so it's 1/2 times 2, all over the total number of data, which they told you in the question were those 30 batteries. Do this computation on your calculator and take a picture. So here you get 0.6. We round that to the percent, which would be in percentage 60%. The rules say to always round up, but here it's exactly 60%, so that means you're exactly at the 60th percentile. So the data value of 6.3 is at the 60th percentile. If this would have been 0.6001, that would have been 60.01%. That would have jumped up to the 61st percentile. But here, since it's exactly 0.6, here your answer is going to be the 60th percentile.